Hello everyone. So as a maths teacher, I always keep on searching for tools which will help me to illustrate simple mathematical concepts to my students very easily. Say so it's advisable to use GIF animations to illustrate those concepts. Say I want to illustrate how the sine graph of y equal to sine ax changes for various values of a. Okay, so here you can see in this image, as the value of a changes, the correspondingly there are changes in the graph of y equal to sine ax. So this animation has been created in the software Geogebra, which is a freely available software, and I use it quite often. So you can have a look at another animation. So this is drawing the polygons, regular polygons of sides 3 up to 10. So starting from triangle, square, pentagon, hexagon up to decagon. Okay, so it draws all the regular polygons of a particular given side. So that is also created using GeoGebra. So it's quite an interesting software. So the main thing is that it's an open source software. It's freely available. So in Google we can type GeoGebra, so you will be taken to the GeoGebra website. There you will see there are several apps to be downloaded. Click on those and download GeoGebra Classic 6, that is the latest version. So you can click on download, and it works on Windows, Mac as well as Linux. So I am using the Linux version. So those who are using Windows, they can download this and install. So once you install it, you can start working with your GeoGebra. So you will get this type of icon. So click on that icon. So I have GeoGebra version 4. So once the file opens, you will see there are axes, there are some grids. So if you do not want the axis, you can just click on this and the axis will go. If you do not want the grid, click on this grid and this will go. You will get a blank screen here. Okay, but the grids and axes are quite important, and we will see how. So once we use them, use the grids, after that we can just remove them. So grids are basically used to position the texts or figures that we will draw in their correct positions. Okay, so the grids will guide us. So in order to create an animation, first of all we need a slider. So you click here and click the slider option, then click anywhere on the screen. So you will get a dialog box of this type. So there are several options. So what do you want to name the slider, that is the parameter, as? So let us keep the parameter as a itself, and suppose I take a to be an integer, or no, let us take it as number only. Suppose I want to plot sine ax for a equal to -4 to a equal to 4 with increment 0.5. Okay, suppose I want to see how the graph of sine of x by 2 also looks like. Okay, so I am using increment 0.5 and then click on apply. So you will see that a slider has been created. A slider has been created here. So now to plot the graph of y equal to sine x, you go to the bottom command line. You will see there is a input written there. So you can type y equal to sine of a star x, a star x. So a is the very parameter that we have already used as a parameter of the slider. So we will write y equal to sine ax and click enter. Immediately you will get the graph of sine ax. So from 0 to twice pi there is on one complete wave. The next wave is from twice pi to 4 pi. Okay, that way. Now see, if you change this a, so 1.5, the frequency changes, increases, a equal to 2. So see, there is one single wave from 0 to pi this time. Okay, so as we increase the value of a, the frequency increases. Okay, and that is what we can observe from the graph. Okay, so and as you decrease frequency, say 0.5, this the curve flattens. Okay. The frequency decreases. Okay. So there is a complete wave from 0 to 4 pi now. Okay. And so 0 minus 0.5. If you go to the minus side, the sign of minus x will be minus sin x. So you will see the curve coming down from 0 onwards. Okay. So there are several such options. Okay, so I want to plot the graph from a equal to minus 4 to a equal to plus 4 and see how it looks like. Okay, so we have already done a lot of work. Now I want a better representation for this. The graph is very small here, so we can change the axis properties. Okay, so how to change that? So for that, just right click here and you will see right click on the axis. Yeah, so you will see there is a graphics option here. So click on that graphics option, and then you can change the minimum and maximum values of y and x. So since sin ax will always lie between -1 and 1, so I don't need minus 6 to 6 on the y-axis, so I can put say -2 to 2, -2 to +2. Okay, so immediately you will see now the graph looks better. Okay, and x you can change it if you want. Say I want it from minus pi, so you can write minus pi, click enter, and I want it up to say 4 pi or 6 pi, let's say 6 star pi, and click enter, so you will get the corresponding value. Okay, so that way we can change this. Save settings and then close. Okay, so we have a better curve here. Suppose you want to change the font size of these labels, so you can go to options, font size, you can click 16. Okay, so the labels are bigger in size now. Okay, that way we can make the changes. Suppose I want this graph to be of different color, we can right click and go to object properties. So there is a color option, so there are various colors available, so you click on any color, then you can change the thickness of the curve. Say I change it to 3. You can also change the line style, say dotted, dashed. Okay, that way. So many options are there, we can use it. Okay, so these are this was the graph. So you can save it, Control S. So you can designate one folder as Geogebra or any other folder. So you can write it as say illustration, any file name that you want to give. So it will be saved as .ggb file, Geogebra file. Okay, so your file is saved. Now suppose I want to write the some caption here. Okay, so what I do, you go to this ABC insert text option and then click wherever you want to put the text. So graphs of y equal to sine of ax for various values of x. Okay? No, sorry, various values of a. Right, so you can click it here. You can change this. You can change the font size, medium, small, large. Okay, so there are various font size available, and then you can reposition this texts, and you can also change the font size. You go to object, change the font style. So maybe this font. Okay, right, then there are other options also. You can change the color as well. Okay, so several options are there. Close. Okay. Now when it is a equal to say minus 2.5, I want that I should get something like y equal to sine of that particular thing written here. Okay, so we can use this latex formula. So y equal to sine of say x and I place it here, and I increase the font size as well, say large. Okay, so I place it somewhere here. Yeah. So this is for the use of grid. So you can recognize which grid line you are using to put this value, so that when I put the next text, it will be almost in the same position. Okay. Now I don't want y equal to sin x to remain in the whole GIF, because as the value of a changes, the curve will change. So when a equal to 1, it is sin x. Okay, not for other values. So what we do is we click here and go to object properties, and then click on advanced. Then you will see that there is a condition here, condition to show object. So object will be shown under what condition? So we want to show y equal to sin x only when a equal to 1. Okay, so we can do that here. So see, in the current value of a is minus 2.5, so it's not showing this y equal to sin x. It will show y equal to sin x when value of a becomes 1. Okay, so that is what. So you can click here and copy, Control C, and then Control V. So let us write it for another one, sin of twice x, suppose. So under what condition I want to show sin of twice x? I want to show this only when a equal to 2. Okay, so that way when a equal to 2, it will show sin 2x, but it is showing in a different position. So we can just reposition it using this grid. So we will remember where we had placed the earlier one. So it will show you in the same position. Okay, so when it's 1, it's y equal to sin x. When it's 2, it is y equal to sin twice x. Okay, so that way when it is say minus 4, so I want something like minus 4x. Okay, so place it here and then change the properties. I want to show this only when the value of a is minus 4. Okay, so that's how I'll do. So when a is minus 4, it's in this position, but I reposition it here like that. So that way you can do it for all values of a, if you want it to be displayed in the GIF that you create. So once you do every such thing, go to file, go to export, and click graphics view as animated GIF. Okay, click this option. Then you will see that you get another pop-up here, a equal to minus 4, time between frames. So it is given in milliseconds. ms means milliseconds. So you can change it. It should not be too fast. Say the slides change after 1.5 seconds, right? And you want the GIF to repeat itself, so you can click the as loop option and then click on export. Okay, so you will see where it is being exported. So it is being exported in this folder that I had created. Okay, so for the time being, let us take it to desktop. Okay, so let it remain there, illustration.gif. Okay, so let us see how this has worked. So this is the Geogebra folder that I had created. So illustration.gif. Okay, so when a equal to, this is how the graph is changing. A equal to minus 1, a equal to 0. Minus 0.5, a equal to 0, a equal to 0.5, a equal to 1. So this y equal to sin x is being shown, y equal to sin twice x is being shown. Okay, if we want to show for every value of a, then we can just use the similar procedure. Okay, and you see that in the final GIF the grid is being shown, so we can remove that by removing the grid, and then again you save it, again you export it to the same GIF 1500 milliseconds as loop export. Okay, so it will ask you that do you want to overwrite your file. So you can overwrite, or if you want to save it in a different name, you can do that also. Okay, so we'll have this option here. So let us see how this illustration looks like now. So the grid is gone and you can see the graph clearly. Okay, so this is how we can create animations in Geogebra. Okay. So I'll be uploading a few more videos to illustrate how we can make use of this animation feature of Geogebra to illustrate many other mathematical concepts. Thank you.